Every serious app has a brain that remembers everything. Your users, their posts, their orders, their messages. That brain is the database, and choosing the right one is one of the most important decisions you'll make. Pick wrong and you'll fight your database forever. Pick right and it just disappears into the background and works. The trouble is, AWS offers more than 15 database services and beginners freeze. So let's fix that with pictures. We'll cover the big fork, SQL versus NoSQL, then RDS, DynamoDB, caching, and data warehouses, and exactly when to reach for each. By the end, you'll confidently pick the right database for any app. First, why use an AWS database at all? Why not just run your own on a server? Because running a database properly is genuinely hard work. You have to install it, patch it for security, back it up, test those backups, handle failover when a server dies, and scale it as you grow forever, at 3 in the morning when it breaks. AWS managed databases take all of that off your plate. You pick the engine, click a few buttons, and AWS handles the backups, the patching, the failover, the scaling. You get to focus on your app instead of babysitting a database. That single idea, managed, is what makes the cloud worth it here. Now the fork that the whole topic hinges on, SQL versus NoSQL. SQL, or relational, databases store data in strict tables, rows, and columns, with a fixed structure you define up front, called a schema. Think of a perfect spreadsheet where every row has the exact same columns, and tables can be linked together. NoSQL throws out the rigid table. It stores flexible items that don't all have to look the same, and it's built to scale out massively across many machines. The quick rule: SQL is about structure and relationships and consistency. NoSQL is about flexibility and enormous scale and speed. Almost every database choice comes back to this one fork. Let's go deeper on relational, SQL, because it's still the right default for most apps. Data lives in tables with a fixed schema, and every table has a primary key that uniquely identifies each row. The superpower is relationships. A join lets you connect tables, link an order to the customer who placed it in a single query. And relational databases give you strong guarantees called ACID, which in plain English means your data stays correct even when lots of things happen at once, critical for anything involving money. The popular engines are PostgreSQL and MySQL. If your data is structured and connected, users, orders, payments reach for SQL first. On AWS, the managed home for relational databases is RDS, the Relational Database Service. You choose your engine, PostgreSQL, MySQL, SQL Server, and others, and RDS runs it for you. Automated backups, security patching, and easy failover all handled. There's also Aurora, Amazon's own cloud-built version of MySQL and PostgreSQL, fully compatible with them, but re-engineered to be faster and to scale its storage automatically. The mental model is simple. It's still the same trusty relational database you know, with the painful operational chores quietly taken care of. You write queries, AWS keeps the lights on. Two features make RDS genuinely production grade, and you should know both. First, multi-AZ. You flip one switch and AWS keeps a standby copy of your database in a second availability zone, a separate building. If the main one fails, it automatically flips to the standby in under a minute, and your app barely notices. That's your insurance against a data center outage. Second, read replicas. Most apps read data far more than they write it. A read replica is an extra copy that handles read traffic, so you can spread heavy reads across several copies and keep the app fast. Multi-AZ is for surviving failure. Read replicas are for scaling reads. Now, the other side of the fork, DynamoDB, AWS's flagship NoSQL database. It's a key value and document store, and its claim to fame is staying lightning-fast, single-digit millisecond responses, no matter how enormous it gets, whether you have 1,000 items or 100 billion. It's fully managed and serverless, there's no server to size, it just scales automatically with your traffic, and you can pay purely per request. The trade-off is that it is not a relational database. There are no joins, and you have to design it around your access patterns up front. For massive scale, simple lookups, and spiky traffic, DynamoDB is extraordinary. DynamoDB is brilliant, but only if you flip your thinking, so here's the key shift. With SQL, you model your data first and write any query later. With DynamoDB, you do the opposite. You figure out your access patterns first, exactly how your app will look data up, and then design the table to serve those patterns. Everything hinges on the partition key, the value DynamoDB uses to find an item instantly and to spread data evenly across its machines. Choose a key that matches how you actually fetch data, like user ID, and it flies. There are no joins to lean on, so if your queries are complex and ad hoc and ever-changing, that's a sign you actually want SQL. Sometimes the fastest database is the one you don't query at all, and that's caching. A cache, like Amazon Elasticache running Redis or Memcached, keeps a small copy of your hottest data in pure memory, so reads come back in microseconds instead of milliseconds. The pattern is simple. Your app checks the cache first. If the data is there, a cache hit, it returns instantly, and your real database never gets touched. If it's not, you fetch from the database and pop a copy in the cache for next time. For data that's read constantly but changes rarely, a user's profile, a product list, a leaderboard, a cache slashes both your latency and the load on your main database. One more specialized tool, because using the wrong database for analytics is a classic mistake. The databases we've discussed so far are built for transactions, lots of small, fast reads and writes like saving one order. But when you want to analyze millions of rows, total sales by region over 5 years, that hammers a normal database. The right tool is a data warehouse like Amazon Redshift. It's purpose-built to scan and crunch enormous volumes of historical data for reports and dashboards. The rule of thumb, use a transactional database like RDS or DynamoDB to run your app, and a warehouse like Redshift to analyze DE, what happened. Right tool, right job. So let's settle the big question with a clear cheat sheet. When do you pick SQL versus NoSQL? Reach for SQL, RDS, or Aurora when your data is structured and full of relationships, when you need complex or ad hoc queries with joins, and when correctness is non-negotiable, like anything with money. That's most apps, honestly. Reach for NoSQL, DynamoDB, when you need massive, near-infinite scale, when your access patterns are simple and known in advance, and when flexibility and raw speed matter more than rich querying. And remember, it isn't either-or. Serious apps happily use both, each for the part of the job it's best at. And here's the most freeing idea in this whole topic. There is no single best database. AWS deliberately gives you purpose-built ones, and great systems mix and match. Beyond the big two, there are databases tuned for specific shapes of data, graph databases like Neptune for networks of relationships, in-memory ones for speed, time series ones for sensor data. You don't need them on day one. But the mindset matters. Instead of forcing everything into one database, you pick the right tool for each piece of your app. The skill isn't memorizing all 15 services. It's matching the shape of your data and how you'll use it to the right tool. Let's make it real with PhotoApp. The core data, user accounts, who follows whom, photo records, is structured and full of relationships, so that lives in RDS, a relational database, with multi-AZ switched on for safety. The activity feed, billions of likes and views pouring in at huge scale with simple lookups, is a perfect fit for DynamoDB. The user's profile and the trending list get read constantly but barely change, so those sit in an Elasticache cache for microsecond reads. And every night, the day's data flows into Redshift so the team can analyze trends. One app, 4 databases, each doing precisely the job it's best at. That is how real systems are built. Here's the whole data layer in one picture. A user's request hits the app. Structured related data accounts and follows. Reads and writes to RDS, which keeps a standby copy in another zone, and read replicas for heavy reads. The high-scale activity feed goes to DynamoDB. The hottest, rarely changing data is served from an Elasticache cache that sits in front of the databases and answers in microseconds. And overnight, everything flows into a Redshift warehouse for analytics. Notice the shape, relational at the core for correctness, NoSQL for scale, a cache for speed, and a warehouse for insight. 4 tools, one coherent system. That is, a real production data is served from an Elasticache cache that sits in front of the databases and answers in microseconds. Let's bring it all together. Databases are your app's memory, and the whole topic forks on SQL versus NoSQL. SQL, run on RDS or Aurora, gives you structure, relationships, joins, and rock-solid correctness, with multi-AZ for safety and read replicas for scale. NoSQL, DynamoDB, gives you near-infinite scale and millisecond speed when your access patterns are simple and known. A cache like Elasticache makes hot reads instant, and a warehouse like Redshift is for heavy analytics. There's no single best, you match the shape of your data to the right purpose. Built tool and great apps cheerfully use several at once. And that is AWS databases, sorted. Not 15 confusing services, just a clear map, SQL on RDS for structure and relationships, DynamoDB for massive scale, a cache for speed, a warehouse for analytics, each a tool for a job, match your data to the right one, and your database stops being a fight and becomes invisible. If databases finally make sense now, do me a favor and subscribe to Beyond Cloud. The whole point of this channel is taking the scary parts of AWS and making them simple, with pictures. Tell me in the comments which service you want next, and I'll see you in the next one.